All right, so thanks for coming to our talk. Seems like we've got a packed house, so thank you all for coming. We're going to be talking about pen testing web services. So we're the web hacking ninja guys. If you're looking for a different talk, different room. All right, so yeah.
My name is Tom Eston. I'm a senior security consultant at Secure State. I'm a web app network pen tester. You probably have seen my previous talks with Kevin Johnson on social media, social networks. Founder of a website, socialmediasecurity.com. I co-host 2 podcasts, Security Justice and Social Media Security. You can find me on Twitter as Agent0x0.
So I'm Jabra, also known as Josh Abraham. For those of you who don't know, I code in Perl. I code
in Python.
Shut up.
Fight.
Shut up. I do penetration testing. I work at Rapid7. We do some cool stuff. We work on the Metasploit project, vulnerability assessment, that sort of stuff. I also do a lot of open source work, contribute to things like the Backtrack Live CD, Metasploit, Nmap, all these other projects, Beef. I do a lot of coding in Perl, so pretty much anything. Also helping people, get through their demos and all that stuff. So
he spent all day coding yesterday for Rich Mogul.
Yeah. So Rich Mogul's demo will be less fail on the fail panel. So yeah.
We are not Kevin Johnson, obviously. Unfortunately, Kevin Johnson could not make it. He had a family emergency, had to fly back around Black Hat. But I definitely wanted to mention Kevin's work in this presentation, and we'll be talking a lot about that. If you don't know Kevin, Kevin is an all-around great guy. He is an open source bigot, as he will tell you. He runs all those various projects that mentioned on the slide there. He's also a SANS instructor, and also founder of pentesterscripting.com, and you can find him on Twitter as Secure Ideas.
So we miss you, Kevin.
We miss you, Kevin.
Yep. All right, so here is the agenda for the entire talk. We're going to be talking about pen testing web services. So initially what we're going to do is we're going to go over like the state of the union of pen testing web services. What are web services? Who uses them? Why would you want to pen test them? And why is this relevant and why do you care? And then from there we'll be going through our methodology that we developed. And from there, releasing some new tools, some new process, a threat model, and then at the end, we're going to do all the demos and also releasing an exploit. So all that cool stuff, all in 1 hour talk. So,
and we hope you like the movie Fight Club.
Yeah, we're
just going to throw that out there.
A lot of references to Fight Club in this deck. So if you pick them all up, let us know.
This is Project Mayhem.
Stuff. We hope you guys enjoy it.
So why do we want to attack web services? Well, we found just through our research, and I'm sure any of you guys know that are pen testers, really those web services are really that secondary attack vector when it comes to any web application. We find that developers, well, just like any other web app, they really don't implement proper security controls. In fact, I would argue that sometimes the security controls are even more lacking than a regular web app because these things are usually found outside of the web application. And of course, that it's assumed that only a client or another web service is going to connect to this. And of course, you know what happens when we assume.
Yeah, and in the industry, we're really pretty good at pen testing web apps. But how many pen testers out there really know about the process of pen testing web services? I would claim very few. So the developers are sort of like getting a free ride. If you have all these web services, if we're not pen testing them, what's their motivation to get them really locked down and secure? So that's sort of the reason why we did this research.
So some recent statistics, just in the mobile space, Kevin Johnson did a little experiment where he downloaded about 200 iPhone and iPad apps, and then he looked to see if any of those were using web services, and he found that actually all of them are using some form of web service, mostly RESTful web services, not necessarily SOAP. But it goes to show you that, especially in the mobile space, we're just seeing web service usage increase tenfold. This statistic here is interesting in itself because it's from a Microsoft Tag, which is Microsoft's implementation of 2D barcodes. That is probably a talk all in itself.
Definitely.
So we won't go there. But this is just kind of give you an idea that with web services and new technology, we're seeing a huge increase. Yeah.
So there's a large attack surface for everybody to start going after, and if the industry as a whole hasn't been really good about pen testing this sort of stuff, there's a huge gap for research, new tools, methodology, process, and probably a lot of vulnerable web services out there. So a lot of stuff. Okay, so in terms of web services, there's really 2 different types of web service, one of which is known as SOAP, and then the other one is known as REST. So as you can see, we're talking about I make and produce SOAP. So yeah, in essence, what SOAP is, everybody knows about web apps and doing like a post, communicating with a web application. Well, that's all well and good. When we talk about communications with a SOAP web service, what we're doing is we're including XML in that request, and the way that we construct that message is known as SOAP. So it's just XML with the SOAP construct, and that's how you would define the data inside of the message. So when you think of a SOAP request, think of email, so SMTP, instead of just a web application where you're making a request, getting a response. You could have multiple systems sending the SOAP message or envelope to other systems. So that's sort of the way to start thinking about it.
So Jabber kind of mentioned about REST, right? So I do a lot of developer training, I talk to a lot of developers, and we've really seen this departure from XML-based SOAP services over to RESTfuls like JSON. So what's interesting, if you don't know what REST is, it stands for Representational State Transfer, and these use HTTP methods like Jabber was talking about, so your get, post, put, and delete. The reason developers like these is because they are lightweight, non-complex, they're good for mobile apps, good for quick data transmission. However though, and I want to make this point important, that SOAP is complex and it's for a reason. And during our pen tests, we find SOAP being used almost all the time in enterprise level applications. And of course, you know, enterprise level applications are holding very sensitive information. Data transfer such as credit card numbers and lots of other things go across SOAP-based services.
So, I mean, sort of right here is where you have the trade-off, right? Do you go after what's widely being used in the mobile side, or do you go after the enterprise? And since SOAP was more complex, we figured we'd go after the more complex stuff because we get a lot of, if you're pen testing JSON and that sort of thing, it's traditionally being used in some sort of web application that's also being used there. So we felt that if we were going to go after SOAP, some of those tools could be backported, since it's all HTTP anyway, into a RESTful web application testing process.
And don't forget large services. We've got Amazon EC2, PayPal, Microsoft Azure. These are large web services that use SOAP APIs, so we can't forget about those.
All right, so now we're going to start talking about a threat model for web services. So initially, right, when you build a web application or web service, the developers always need to know, what do you mean when you say a secure web service? What does that actually mean? Well, there's tons of different things. Usually when you have a web application, we want some sort of authentication if there's valuable data there. Also, we have to encrypt our traffic, so making sure that that's encrypted is a very important thing. A lot of developers, if they miss that step, we don't really need to do much else, because you can just hack one of the systems and then just sniff all the traffic. And when we get to the exploit, you're going to see how that's really, really useful. But in essence, there's tons of elements here, and we can't cover all of the different attack vectors. But one of which, if you think of XML, right, it's a really complex language, and you have all these SOAP things, so you have to be able to parse and look at that type of information. So potentially bugs in a parser, or the potential for injecting like code or commands into the application. So one of the things we're going to be talking about later is a sample web service, and you guys can see how that works. But you're going to get all the different attack vectors. SQL injection could be possible through a web service. If you're looking at passing username and password, there's potential for a lot of different flaws which we're seeing in web applications. It's just a different way of communicating. So here, if you take a look, either way, if you start out by having node 1 is going to be transmitting information all the way to node 5, well, if you're using SSL, that's going to be encrypting or securing your data in transit. But what does it do for the data on that box, right? If there's a sysadmin who's malicious, or maybe that one of those boxes, intermediate systems, gets hacked, what do you have to do to basically protect your data, right? What's to stop somebody from modifying the information, replaying that traffic, or just dropping your traffic? You don't have any assurance as to that type of a protection. So in that sort of a case, you may want to consider actually encrypting the entire SOAP message to provide that type of security, if that's an important thing. So in terms of who would use this sort of thing, you could have various third parties, so one organization transmitting to another, and then that information could be transmitted to another. So depending on how you're using web services, you would have to construct a threat model and protect against those different attack vectors depending on your use case. So in some situations SSL may be enough, but in others it may not work.
So the state of the union here, really through our research, we found that there's issues with all kinds of things with web services. So how to properly scope a web service pen test, tools, testing process, methodology, techniques to test, education for developers and vice versa, and testing environments. So basically we come up to the conclusion that it is all broken and we have to do something about this. Like a single serving friend. So what we found too is really pen testers really don't know what to do with web services. I talk to a lot of pen testers and there's always this it seems like this mystery with web services, like it's a magical art to test web services. And really what it comes down to is it starts with scoping. So are you asking the right questions? Are you asking about web services when you scope out like a gray box web app pen test? Do you even know that there are web services in that application? Web services may be the most critical part of that web app, and if you don't ask the right questions, you're not going to know until you get into it, and then you find this out, and then you come across a couple hours later, and you've got to rescope the whole thing, and that wastes a lot of time and it wastes money. And of course, how do you test it? So do we use an automated approach, more manual? Unfortunately, most of the stuff we find is around manual testing. So, and of course, manual testing takes a long time, and when you have 1 or 2 days on a pen test, that's usually not feasible. So going to the testing methodology, really the only great guide that's out there, or guide at all, is the OWASP testing guide, which has a web service component in version 3. The guide itself is a fantastic guide for all web app pen testing, but however, the web service piece is really outdated. It's missing full coverage on recent threats and different types of threat models. So for example, man-in-the-middle attacks, client-side storage, host-based authentication. It's focused on old technology, so no mention of WCF services from Microsoft or how to test multiple protocols such as SOAP over TCP.
Right, and the other thing to keep in mind here is if you think of SOAP, it's actually been around pretty much just as long as SQL injection, and yet how many people in this room really know how to pen test for it? I mean, at the end of the day, it's an important thing. It's out there. Developers are using it, and developers are so far ahead of everybody in the industry in terms of pen testing these web services that we're playing catch up. So.
Yeah, developers really have gone down that road of functional testing, and there's lots of tools out there for functional testing, like SOAPUI and things like that. And we're seeing more recently that they're adding more security features into these tools, but it's just now that people are talking about this stuff. So tools, well, they just suck. I mean, let's be honest, right? There's commercial tools like I mentioned. SOAPUI. They provide more functional testing for developers. You'll see them all over the place, but there's very little automation. A lot of the tools that we find, they're just missing features, missing functionality. They're not open source, so you can't contribute, you can't change code on the fly or customize it for certain situations. So what we find is that we end up writing our own stuff, writing our own scripts, writing our own tools, and of course that takes time, and that takes time away from actually hacking, which is that's what we really want to do. So, just a question, what happened to things like there was an awesome little web service module in EBSCARAB, and that is actually being depreciated. I don't know why. So that's unfortunate because that actually had some good functionality. But who actually uses EBSCARAB as a web proxy anymore? Probably nobody, right?
I prefer BURP.
Yeah, everybody kind of prefers BURP. But things like WS Digger, that was kind of the de facto tool at one point. You just throw a WSDL at it and it does a little bit of checking. But it doesn't support SSL. So what the hell? Little things like that. So we find lots of problems. Java really likes doing SOAP messages written by hand.
It really sucks. Yeah. Please.
Yeah, these are things that just really suck and take a lot of time. And of course, we find tools are broken or just not working properly.
Or you got to sit down and code this thing in 13 hours or whatever it is. And if it's custom and it's to get the job done, it is what it is. You either do that or you have a different process.
All right, so here's the web services module that they actually show it on the website of this module will be depreciated. So instead of depreciating, I think we should improve it. But oh well. Here's WS Digger. Everyone's probably familiar with this. Just doesn't cut it these days in terms of tools. Another kind of decent one was WS Scanner that came out about a year ago. This is great and everything, but it only supports .NET web services, so you're kind of screwed with anything else.
So I have clients who use other technologies, don't you?
Yeah, I kind of do. So this is kind of an example just showing you where all these gaps are, and it gets frustrating when you're on a pen test and you're trying to use these tools. You run into these roadblocks, and roadblocks is what we're trying to get around.
Yeah, so our current process for pen testing web services prior to this talk was to basically use SOAPUI, which is really just a QA tool. The recent versions have included things like, some security features. But when I looked at the interface, it was kind of difficult to use or just didn't make sense to me. So I was like, all right, well, I'll just sort of, go off and do whatever. But SOAPUI, and then what we would do is to use Burp Suite as a web application proxy. So since it speaks HTTP, beautiful. We'll just use SOAPUI and have SOAPUI use Burp Suite as a proxy, bootstrap our HTTP post request, and then use the intruder, and then just teach Burp Suite about web application or web services testing.
Yeah, I wanted to mention Ken Johnson. He did some really good work around this area. He's got a great article. I definitely recommend everybody checking this out. He's basically taken the functionality of Burp Suite. He's written some Ruby scripts and put them into Burp, so you can kind of do the SOAPUI functionality within Burp now, which is really cool. But it kind of goes to show, we've got to write our own custom stuff like this, and this takes time, billable hours, and it just really sucks.
A lot of people in the industry who are pen testers are not really, awesome coders, right? And not everybody's going to be an awesome coder, and that's fine. So at the end of the day, we need to look to alternative approaches to improving our testing process because, writing code takes time and/or not everybody has that type of skill. So to get the job done, we gotta approach the problem a little bit differently. So here's just a couple screenshots of using SOAPUI, and this is just a simple request. And then from there, what we'll do is we'll set up the proxy, localhost 8080, and we would use Burp Suite to intercept that request. And then from there, we can use the intruder to do fuzz testing against the web service. So here's just a simple example of a public web service, and we're just sending, some information, and then from there you would just leverage the intruder or the repeater to replay this request, do some fuzzing, looking at interesting parameters here, and then
you would never fuzz a public web service, would you?
Oh, absolutely not. Definitely not.
So, now going into kind of testing environments for web services. So I got this awesome new tool, this script. I've done a lot of work here. Where do I test this thing? Do I test it on a public web service?
Production environment.
Or production environment? That's awesome. That's not illegal or anything, right? Or just build my own testing environment, right? I'll do that during the pen test, right?
How good are you at coding?
Yeah, exactly. So there's a big gap here. I think WebGoat had a little web service component at one point, but I don't really know anyone that uses it or if it was that good to begin with. So we kind of started with ground zero here, and we want to provide some value around how can we do this in a good testing environment that's open source and contribute it back to the community. And if you ever see an online pregnancy test, yeah. What the hell is that, right?
Fail.
So what are we going to do about all this? We've seen a lot of problems here. There's problems with pretty much everything. So, of course, keep calm and make soap. So what we're doing is we're taking the information from the OWASP testing guide version 3, and we've completely revised it with the newest technology that's out there for web services, and we are contributing this back to OWASP for the testing guide in version 4 that right now is under development. The big thing that we're changing is from a high level, I want to keep that in mind, from a high level we are aligning that with the PTES, which is the Penetration Testing Execution Standard. So if you don't know what that is, it's a large project that's going on right now in the security community, led by guys like Chris Nickerson and others that are really trying to define what a penetration test is. So getting away from the vulnerability assessment versus a pen test.
A pen test is not a vulnerability scan. A vulnerability scan is not a pen test.
Right. But setting standards around this so you can take this to clients, take this to customers, whoever, and they'll know what a pen test is. And it really helps define a methodology for any type of pen test, which is very important, especially when we're talking about web services because they are so complex. So breaking this down from a high level, obviously our white paper that we'll have links to at the end has the full excruciating detail that you can go through. But it really starts with the pre-engagement interactions, which is your scoping questions and goals, defining what type of assessment this is, and of course your rules of engagement.
Do you have web services? That should be a question.
For any type of web app engagement, exactly. Intelligence gathering, so this is where you're going to define your WSDLs, you're going to enumerate those WSDLs, you're going to look at WS security controls that may be in place or may not be in place, authentication credentials, sample SOAP requests, and identifying those awesome web service interfaces, which Jabber is going to be talking about in a second.
There will be exploits.
Yep. And that's something that gets overlooked a lot by pen testers and the clients, of course. The other important phase here is the threat modeling. So asking the client, looking at the application, looking at the web services and saying what is most valuable from a business perspective. If there's credit card information going through those web services, you're damn right that's important, and that's something that you're going to have to test for.
And talking with developers is probably the best way to get a really good understanding of the threat model, right? So understanding the business is critical, but then talking with the developers, how did you implement this thing? How did you build security into this web service? I got to understand how you did it, because that's the only way, in some cases, that we can provide assurance that it's even close to good.
And when you're doing your pen test, you want to outline a realistic attack vector. So a web service that's only used internally versus one that's accessible on the public internet is going to have a completely different threat model, and you need to define that ahead of time. Next up, we got vulnerability analysis. So this is where we're going to actually do our testing. We're going to do the authentication testing, transport layer, web service interface management testing, and analyze client-side applications, which we'll talk about in a little bit, like Microsoft Silverlight, that interface with web services. And then, of course, the fun part, right? Exploitation. So we're going to do our content level testing. We're going to be fuzzing. You may want to use Jabber's new Metasploit MSF Web Fuzz module, which we'll talk about. And, of course, doing replaying, man-in-the-middle testing, and then Beeple, which we have a whole slide on Beeple, right? Then once you have shell, hopefully you do have shell, because you can get shell through a web service, which Jabber will demonstrate. You want to prepare and document, and, of course, reporting at the end of the day.
Reporting is the necessary part.
It sucks, but we got to do it, right? So scoping. This is a big piece that I want to spend some time on. This is critical, absolutely critical when we're talking about testing web services. These are the types of questions you need to ask. So things like determining what type of framework. So WCF, Apache Access, Zend. You have to know that to start off with. The types of services. Do they use REST, SOAP? What type of data? Provide all those WSDL endpoints and paths. We need to have that in advance to do the testing properly. What type of authentication does it use? We find that some clients are setting up this, strange custom authentication, and if you don't know that ahead of time, you're going to be in a bind once you start figuring out how that web service works. Definitely have the client provide multiple SOAP requests in advance, showing the full functionality so you can do your testing and you're not wasting time trying to figure out all that stuff on your own.
So without a sample web service request, in many cases, what you would often get is a WSDL. And the WSDL just says, here are the functions, and here's roughly what the data would look like. But you actually want to be able to make valid requests and see what valid responses would look like. And then look at the invalid requests, right? So you want to see both, right? So understanding that if we have a sample web service request, that'll be super useful when we're actually doing the pen test. All right, so now when we're doing fingerprinting, right, we're going to go off and try to enumerate where are those web services on the internet. So ASMF, Microsoft Technologies, but there are also tons of others. And the WSDL, right? The WSDL is what you actually would specify. It's sort of like the data definition for communicating with a SOAP web service. This is just, as I said previously, it defines all the methods and all the different types of values that would be passed to this web service. From there, you can also look at, using things like Shodan and Google to do this enumeration.
Shodan is awesome.
Yeah, Shodan is awesome. It's so much win. Definitely makes reconnaissance really, really easy, especially when you're looking at web applications or web services reconnaissance. It's definitely the primary method that I would use.
And something that kind of gets overlooked now, I mean, Microsoft Silverlight is kind of a newer technology, and we're just starting to see a lot of research coming out about, around the security of Silverlight. But I'll talk about this in a second. But Silverlight, the ZAP files, if you search for those in Google, they're usually tied to web services. So you can look at the client-side app and then see where those services are exposed and then go from there.
Yep. Okay, so here are some of the results. We just did a quick Google search. Take a look at this. I mean, this is right now on the internet. This is pretty much what we found. So, it's definitely out there. And if, as an industry, we're not really good at pen testing it, it's pretty much like, all right, well, there's some risk there. So here's Tom's password, because one of the things that we've basically seen is that in the industry, Weak default and reuse passwords, from my point of view, is most organizations, that's their biggest risk, right? So when you think of when you go in to do an internal pen test, pass the hashes is a nice example. You crack one Windows system, reuse the password, you'll probably compromise the entire domain. So that's one thing that we've seen as a very useful vector. So I did some research last year on SAP Business Objects, and they had a default username and password, and we were able to get shell on this box. So that was through a web services management interface, right? So thinking about not just the web service, not just the web application, but also the other interfaces that control that stuff, right? So some of the developers may not even be logging in to these web management interfaces because they may not need to. If the security guy doesn't know about it and the developer doesn't use it, well, it's still there and it's a huge risk in the industry. And if it's a documented username and password, the attackers can, they can do a quick Google search and find this stuff. So we need to be able to translate that into a Metasploit module or something else and basically demonstrate that risk.
Yeah, developers really, talking with them, they have no idea that these web service interfaces are out there. So they're actually kind of surprised when we make this a finding, and they're like, oh my God, we left this wide open, and it's kind of shocking. So.
Yeah, access to, exposed on the internet with default credentials is code execution. So, All right, so one of the things that I'm going to be talking about for this year is Oracle GlassFish, which is something similar to Tomcat Manager and JBoss and Access2. It's basically like Access2, which is for handling and deploying web services, but there's tons more functionality there, right? So it runs on a unique port, which is 4848. And the idea here was that if you took the same approach that we've been taking to Tomcat Manager and Access2 and apply that to GlassFish, potentially we could get shell through this application because it does allow for the ability to deploy a malicious web or a web service. So we could just deploy a malicious one if we could get authenticated to the application or maybe bypass authentication. So in the industry, one of the things that we've seen is that there was a documented CVE, which is a known authentication bypass for earlier versions of Oracle GlassFish. So there's, Oracle had, previously they had purchased Sun, and what Sun had was, it was 2.x and Sun Application Server 9.x. So there were the earlier versions, and also it affects GlassFish 3.x. So those were the earlier versions that the authentication bypass affects. But in the later version, 3.1, there is also a default username and password. So it's admin blank password, right? So as an industry, we've seen from SQL Server, SA, 2011, and we're still seeing that sort of stuff. So as an industry, it's gone across the board, multiple organizations. They're documented, so they're public. So how do we find this sort of stuff? Using Shodan. We're good enough. You just type in GlassFish, about 1,400 systems on the internet. So it's definitely out there, so something to be aware of. And it was documented. So it was documented functionality. So from that perspective, it's not really ODay because there is no patch. There probably won't be a patch because there's nothing they can really do about it. We just needed to make sure that the security community was aware of, you can get shell on this box, if you have this documented, admin blank password.
Of course, once you have shell and you have access to the internet server, you can gain access to all that data.
Well, this is the
web service.
This is the system that's going to be running the web services. So if we just do a packet capture, we're going to be able to get all that customer data anyway. There's not a lot of work there. All this web services stuff and the SOAP and communicating with XML, that's really hard and a lot of work. So somebody who's just like, all right, I just want to demonstrate some risk really, really easily, the script kiddies of the world or, whatever it is, or even doing a vuln scan. You could probably pick this up in a vuln scan, so relatively easy to do. And then from there, the client needs to understand that risk. So I worked with a couple other guys on this from the Metasploit team and some contributors. So from here, we got the exploit working really, really beautifully. So if you guys want to try it, right now, it's already in the Metasploit SVN. It does version detection for you, and then it does the best type of approach first, and then it will walk down from there. So on GlassFish 3.1, you have default credentials. For the earlier versions, 3.0 or Sun Application or GlassFish or Sun GlassFish 2.x, what it will do authentication bypass, and then it will try the default credentials on those earlier versions. So those are fully documented, and that works great. So you're going to get shell on a whole lot of different versions. There's commercial and the open source. It works on both. I tested this pretty extensively. If you find any bugs, please feel free to email me. But yeah, we'll do demos at the end so we can get shell.
So we talked a little bit about Microsoft Silverlight and some other expanded attack services. Silverlight's really kind of a newer client-side application type technology that Microsoft's developed, but we found that it can use web services and it can use it extensively. So it's more than just a flashy banner ad. You can develop entire applications in Silverlight. And they use WCF, which is Windows Communication Foundation. If you're not familiar with that, it's a newer web service technology from Microsoft. And what we found is you can really pretty much discard the application itself once you know what web services it's interacting with and attack the services directly. So developers like Silverlight because it pushes a lot of the client-side processing and things like that back down to the client, and all you've got is these lightweight web services to transfer data. So it's becoming more of a popular thing. So the security we found really depends on how you configure those WCF services, and that's really the attack vector there. And we also seen a lot of complexity, especially with AJAX and Flash implementations that are leveraging web services. So great question. I know Jabra, I think you ran into this. You know,
yeah.
What if AJAX calls to web services are made from the DOM?
Yeah. Now you got to basically fire up Firebug, yep. And then just start reviewing that stuff because it's not going to be going through the proxy in that sort of case. So.
Exactly. So we've also seen a lot of different types of attacks being documented. I wanted to definitely mention wsattacks.org by Andreas Flackenberg. He's done a great amount of work here detailing and cataloging pretty much every type of web service attack that's out there. I mean, there's stuff out there that I never even heard of before. And it's an excellent bit of work that hopefully he's going to be bringing this back into OWASP and bringing it back into the community. But he catalogs everything around SOAP and Beeple services, and you definitely need to check that out. And we've tied this into our methodology as well, so we've referenced where you can see these different attacks on his site and back and forth.
So no need to duplicate the efforts that have already been made. We want to basically reduce these locations because there's so much attack surface. We want to basically have one location for everybody in the industry to go to. When we say we want to pen test a web service, here's the location. Go.
Yeah, and one thing that we're finding too is that we're finding SOAP requests now that actually provide content back to the web application. So Kevin has designed an actual vulnerable web service where you can demonstrate persistent cross-site scripting through a web service, which is really cool when you think about it.
All right, so this thing called Beeple.
Beeple.
Right? How many in here have actually heard of the word Beeple, right? Do you guys know what this stuff is? All right, show of hands. Not too many people, right? All right, so for those of you who don't know, Beeple is like if you have multiple web services, right, in an organization or even with a third party, that sort of thing, Beeple is the way that those web services could communicate, and you can document that sort of thing in XML, right? So you can have an XML parser for the way that your web services would communicate, and that's all represented in XML, right? So there's an XML, there's an XML parser, that's a whole lot of stuff. But in terms of the industry, we can't really, we're not sophisticated enough right now, I don't think, to pen test Beeple. So the best way to approach that sort of thing is with a developer and sit down with developer interviews. We're not even good enough at pen testing web services, so we need to improve that state to get to pen testing Beeple. Because when you think about multiple web services communicating based on conditionals or whatever situation is there, we just don't have the tools to do it. So a white box approach is my recommendation in those such situations. All right, so now we're going to get to some of the cool stuff that we did and improving the state of the industry. One of the things that I did was I was looking at the current stuff in Metasploit, and I was like, all right, well, the current methodology is to use SOAPUI to communicate with Burp Suite, or to use Ken Johnson's stuff and add the plugins and then do a lot of coding outside of Metasploit. So two things that I did here was I basically wrote up a quick HTTP repeater that basically take a SOAP request and send this off to a web service. And then the other thing that I did was to do a quick HTTP fuzzer so that we could actually demonstrate how we could find these vulnerabilities with Metasploit. The next step will be to basically leverage some of the modules that I wrote to be able to construct these payloads like a PHP interpreter and actually get that included so that you can actually get shell if you find something like a command execution, that sort of thing.
Right, so this is only the beginning when it comes to testing the web services in Metasploit.
Yeah, this is only the way beginning, right? This is like a call to arms. Everybody needs to get involved with this stuff. So if you're pen testing web services, you want to help out, let me know. We can definitely code some stuff up. So yeah, let's get to it. We're going to save all the demos to the end. That way we can go through everything and we won't skip anything.
So Kevin spent a lot of time working on, let's find a way that we can have a good testing environment that's open source, give it back to the community where we can test these things. So he basically has created an addition to Damn Vulnerable web application that was created by Ryan Dewhurst, and it's now another piece of that application called Damn Vulnerable Web Services. So this provides really an awesome a great set of things to test in terms of all kinds of vulnerabilities. So it uses the Damn Vulnerable Web App authentication by default, which is nice. The only thing that I like about it too is it offers high, medium, and low difficulties. So if you're just testing some simple things, or if you want to get more advanced, that's all available for you now. There's a WSDL available for each service, and then you can test reflective as well as persistent vulnerabilities.
So this is going to be super useful because we're going to be building a lot of new tools and improving our testing methodology. So this is going to be what we're going to leverage to verify that our stuff works, right? Because there's no other way to do that. I mean, you have production environments or testing labs or that sort of stuff. Here it is. This is going to be the location, and also doing training around your pen testing team, making sure that they can pen test and demonstrate risk for vulnerable web services. So this is perfect.
And the other thing is it's also extendable, which is great. It's open source. You guys can look at the code, make modifications, and do what you want with it. He's also going to make this available in the Samurai web testing framework.
Yep,
so
also
a great testing framework, live CD that you can download, pop it into a VM, and then test this stuff on your own. Pre-configured, ready to go.
Perfect. All right. So starting out, right, SQL injection, SQL injection over web services, right? Not too difficult, right? Username and password transmits to a database. You get the response. Well, great. And the various levels, right? You could have blind, you could have error-based, all the different types, union, all that stuff. So tons of work here. The next example is the code execution, right? Command injection. This is going to be what we're going to be demoing to get shell to demonstrate some real true business risk and really just drive that home. And also we have the higher level for this particular web service is blind command injection. So good stuff. You want to talk about the
yeah, this is my favorite. So a persistent cross-site scripting flaw through a web service. This is where if you find a web service that is publishing information back to the web app, if I can inject some JavaScript into that web service request, I can get that to show persistently back to the user. So the challenge with this is this actually posts it back to the main web application within Damn Vulnerable Web App to kind of show you, if they're not doing proper input validation, that you can get that to pop. So before we jump into the demos, just to kind of conclude here what we're talking about today, so pay attention to these new attack vectors. The technology is rapidly changing. You talk to these developers, and they are jumping on this stuff like crazy. Just the other day, I was out doing an engagement, and I had a client ask me, what's the best practices around Microsoft Web Services? And I had to do a little research because there's not a lot out there yet. I could tell you how to attack them, and they're like, well, I want to know how to defend them. So you have to, right now it's very immature from a security perspective in that area. And so they're really ahead of us with developers and their functional testing. We need to play catch up, unfortunately. And of course, this work is only the beginning, so you need to get involved with OWASP, contribute to open source projects, try your hardest to get developers to do the same. You may have to get violent with them, but sometimes you have to with developers, right?
And if you want to get involved and you're not a coder, feel free to let us know about anything that you're seeing in the industry, right? If you're seeing web services that are communicating in different ways or things that we haven't thought of in our threat model, let us know. Like we're on Twitter, so it's very easy to find us. Any reply will, you'll definitely have my eyes on it, so let us know.
And you can SVN update right now to get the GlassFish exploit?
Yeah, so the GlassFish exploit is already in Metasploit. I'm going to demo that in a couple of seconds.
Yep, and then these two links, these links will not take you to bad places, I promise.
Yeah.
And that's where you can get the link to our white paper, and then Jabber is going to be posting the WS modules.
Yep.
You can download.
They'll all be available.
Yep. And then DVWS is going to be available through that URL right now. You can download that now, check out the code, and it'll also be available in the next version of Samurai, WTF.
Awesome. Let's get to some demos.
Demo time.
All right, so the first demo we're going to do is the GlassFish stuff because I know you guys want to see shell pop right now. You guys are like antsy. All right, so can you guys see this? Right, so this is Oracle GlassFish. It's running on 4848. So all I did was I used Metasploit to basically construct, authentication, username and password to be able to demonstrate and get shell. In terms of doing how to actually build this exploit, all I had to do was to sit down and use Burp Suite to intercept and identify what did I actually have to do to make this type of post request. So here we're just setting the host name, setting the payload, and it's providing this functionality. So all we need to do is just take a look at the Tomcat Manager exploit, generate a RAR, upload exec, and then execute. So there's another application interface, which is port 8080. So you see set R port or app underscore R port. So you have to make another interface request to that interface. So here all we're doing is we're doing GlassFish, 3.1, finds the version, uploads, gets shell, interpreter. Now we're going to do the cleanup because you don't want to leave stuff on the box, and then it just does the undeploy. So that's shell on the box. Latest, fully unpatched. Or actually, it is. I mean, it's up to date. So there's no way that they could patch this. So shell. All right, so this is the web fuzzer, and this is just like a sample post request.
That's an awesome fuzzer. It's blank.
Hang on.
Ooh, other screen.
Two seconds.
There it is. Cool. It's that Dell you have.
Shut up. This is why we record demos. All right, so we cat the post request. This is a sample web service with SOAP. Too dark? Can we dim the lights for a second? Kind of a dark demo. Sorry.
There we go.
Is this better? Can you guys see? My lights are dim. All right. Well, we're going to upload all the demos online afterwards, so they'll be on. I'm going to post on Twitter, all that stuff. So you guys can find me if you want to see more demos. If you guys can see this, all I'm doing is using the MSF web fuzzer, sending in the post request, and then sending in a file, which basically has all of the elements to basically use and fuzz inside of the post request. So here's request 1, and then we're going to do request 2.
And we get take a fuzz list from like
yeah.
FuzzDB or wherever. Burp has a nice one too that you can import.
All right, so here what we've done is we've actually identified that we had command execution through the web service. Just put in the word ID, and then from there we can get, we're going to be able to get code execution on the box, so we're good. All right. Now this demo is basically just doing a few different things, right? The first thing we're going to do is we're going to have to generate a PHP interpreter, store it in shell.sh, and then from there we'll upload it to our attacker's web application, and then from the web service, download and execute that shell. You just copy it in the web root. All right, so for this, as you can see, we got right here, it says wget -o msf shell.php. That's basically because we have to have the shell interpret this as PHP code rather than TXT. So now we did the wget, should be on the server. All we need to do now, execute the command, and we'll get shell. So we have our interpreter. We're going to set it up as a listener on 444. And now we're just doing the wget to make sure that the PHP shell gets called, and then we'll see the shell on the interpreter side. All right, so there's our PHP shell. Great. So I wanted to show a couple more demos. This is the Oracle GlassFish authentication bypass on Sun application 9.x. So these is like the earlier versions of GlassFish, and we can just use a lowercase get and or post request to just not even need credentials, right? This is a CVE that they claim they fixed. So there it goes. It's detecting the version, trying the authentication bypass, and it's going to do the logical attack vector based on the version. Successful authentication bypass, we're good.
So you can kind of lump this in with the the JBoss, Apache Tomcat modules, very similar functionality.
Yeah, and if you look at the code for this one module, it's like an Uber module because it works on like, I don't know, like 8 different applications.
Waiting for shell. Waiting
for
shell.
Shell. And it does the cleanup just the same. So there's one more demo that we wanted to do. So I did some custom web services modules. I did a auxiliary scanner to be able to detect one of which, one thing was all the different actions for a web service. We need to be able to enumerate those actions because they're sort of like functions. We need to be able to make those calls to those various functions and then pass in data to either get shell or do some sort of SQL injection or code execution, that sort of thing. So I'm just demoing using public web services to show that functionality so that you could reuse that exact demo and then get the same result. Shouldn't be pen testing public web services. We're just using them as a normal developer would. So you can see there's a get quote function from the public web service, and we're just going to ask for the stock of something like that, like Microsoft. So here what we're doing is we have a SOAP basic request based on a WSDL, and then it will just, from there, use this particular action, get quote. So what it's going to do is it's going to use the WSDL to generate the SOAP request, and here is the response. So I basically converted the response and using Ruby to basically just dump all of that data to the screen. It's an alpha version, so figuring out what is the most useful response, I wasn't really sure. But as you can see right here, we have all the data that we need, so we're good. and that's all going to get incorporated into Metasploit. Talking with those guys, I'm figuring out when exactly this stuff will get merged in. The glass stuff exploit is already in the tree. This other stuff, we just need to plan and figure out when is the best time to get that stuff merged in.
Yeah, you'll be able to download that from Jabba's blog, right?
Yeah. Yeah, I'm going to make it available. It won't be an SVN for Metasploit, but it will be available, as a tarball or zip file, whatever. So that's pretty much what we got.
All right, guys.
So, thank you all for coming.
We'll be in the Q&A room.